so I'm back. I did the 3 GB switch. I rebooted the system, restarted Maya, opened up my save scene from the last point where it had crashed, where Mental Ray had crashed because of the memory problem, and we're good to go. So let me check my lights here, make sure that they are using 2 million photons, which is what I want. And there we go, 2 million photons, perfect. So let me close that. Let me also go to my render settings. Let me go to indirect illumination, or indirect lighting I should say. Close that final gathering. It's always opening up by default. It's very annoying. Okay, over here for rebuild photon map, I want to make sure I give the photon map file a name. I had called it apartment before. At some point in time, it was deleted. Okay, so we'll call that apartment.phmap. Perfect. Okay, let me close that. This time we're going to go ahead and render this out again. So let's go ahead and hit the render button. I'm going to open up that output window so that I can monitor the progress, or not the progress, but monitor any warning or error messages that might pop up. Hopefully that won't happen again. Shouldn't happen again. And there's the photon emission down here in the lower left, the status bar. Looks like it's going along pretty slow. It is 6 million photons, so it takes a little while to calculate this. And I'm just going to pause the video and come right back as soon as it's finished. Okay, so it wrapped up the photon emission. We can see so far in the output window we have no errors. Everything seems to be going along pretty well. Over here in the output window we can see it's optimizing access to a photon map with 6 million photons. And it right here it tells us that it wrote the photon map file to the disk. And it's actually rendering out. No errors, no crashes. Everything is going along according to schedule. Okay, and it wrapped up. Let's go ahead and minimize that that output window. Now we can see that our global illumination result looks pretty good. It's pretty even, pretty smooth, pretty accurate too. Looks pretty nice. Only took 1:43 to render that out. Awesome. Okay, so let me close this. I'm going to go back to the render settings. Now that I have this apartment pH map written to disk, what I'm going to do is I'm going to turn rebuild photon map off. That way we don't sit here and recalculate that long photon emission over and over again. I can do an IPR render now, and it'll render out pretty fairly quickly here in just a few seconds. Thanks of course to the fact that Mental Ray allows us to keep reusing the same photon map over and over again, which is a great help. Alright, looks pretty good. Photon map looks pretty accurate, very nice. We don't have any blotching and stuff like that. Looks fantastic. I like the way the shades look. And the walls look pretty nice. Same thing with the ceiling and furniture. This is looking pretty good. Okay, but there is one thing missing. One thing you want to do when working on scenes like this one, especially if you're going after photorealism, is something called tone mapping. Some areas of the image in our CG render are going to be blown out of proportion. Some areas are just going to be too hot, that is to say, too bright. We need to bring in something called tone mapping to even out those light levels and to make things look more realistic and nicer. The way that things would look more in a photograph, or the way that things look more to the human eye. Okay, and CG images just can't produce that by default, so we have to apply some tone mapping. So how can we apply tone mapping to the render? Well, it's pretty simple. There's a couple of ways we can do it. We can do it in another program like say Adobe Photoshop or some other image editing program, or we can do it right in Mental Ray using special Mental Ray shaders designed specifically for tone mapping. So what we want to do is apply a tone mapping shader to the camera lens inside of our scene. And the camera is what we're looking through right now. If we apply a tone mapping shader to that camera, we're going to be able to apply nice tone mapping to the final render. So let's go ahead and let's see how that works. Before I do, however, let me go ahead and pick an interesting angle here. Maybe I'll pick this angle right here. Looks pretty good. I'm going to do a render from this angle. It's not going to take too long. There we go. I'm not using really high anti-aliasing settings at the moment either. Okay, 30 seconds, not too bad. So this is the way it looks right now without tone mapping. I'm going to go ahead and save that image. Okay, I'm going to close that, and what I'm going to do is I'm going to go ahead and apply a mental ray tone mapping shader to the camera that we're using right now to view this scene. To do that is pretty simple. I'm going to come up here to this set of menus up here in the viewport, and I'm going to go to the view menu. I'm going to click on select camera. That's going to go ahead and select the camera for us. Let's hit Control-A to open up the attribute editor. And now what we can do is scroll down here, and we'll see a section for mental ray. Let's go ahead and open that up. And we can apply 3 different types of shaders to this camera. We can apply an environment shader, a volume shader, and a lens shader. The tone mapping shaders that come with mental ray will work in the lens shader slot. So let's click on this checkerboard icon here. That's going to open up this create node window, and we want to make sure that we're in the mental ray tab over here, which you should be by default. If not, just go ahead and navigate to that. We're not going to use materials, so let's collapse that, collapse shadow shaders. We're not going to use any of these over here, so I'm just collapsing them, getting them out of the way. The one that we're going to be using is down here under lenses section. So we have all these different types of shaders that we can apply to the camera lens. Okay, the one we're going to use now is this one over here. That's on the right, top right, called MIA Exposure Simple. So let's go ahead and click on that. That's going to apply the Exposure Simple shader and open up its attributes over here. Okay, so these attributes don't go anywhere. I'm going to come up here to this list menu, and I'm going to uncheck the auto load selected attributes button here. That way, if I select other objects in my scene, either on purpose or by accident, it won't change the attribute editor on me, which can get pretty annoying. Okay, so with that done, let me go ahead and create another render, and this render will be done with the default tone mapping of this shader. Okay, so here it is, 23 seconds, not bad. If we go back to the first image, this is the first image we had without tone mapping. Notice how hot this area is back here, how bright it is. And notice how the back area of the room over here becomes very, very dark. In other words, there's a very high amount of contrast, almost as if though we took this render into Photoshop and we adjusted the contrast to very bad levels and pretty much destroyed the image. This is the way that it renders by default in mental ray. By applying this lens shader, we were able to even that out back there. If you notice, now it doesn't look like it's burned anymore. It looks more plausible, more believable. But the problem is, now our image here is blown out. It's very pale, very washed out. We can change that by changing the gamma here. So I'm going to do that. I'm going to change the gamma to about 1.4. I'm going to render this out again. You can automatically start to see that the gamma correction there fixed it up pretty good. Now it's not all washed out and nasty like it was before. Looks a lot better now. But it still looks a little bit washed out, just a bit. But it looks much nicer. And we'll compare it with the first image as soon as it's finished. There we go. If we go to the first image, we can see that the second image looks a whole lot better. The colors just look a little bit nicer. Yes, it does look a little bit washed out, but you can see that back here in the first image, it looks blown out. It looks very CG-ish. Doesn't look very realistic. In this one, however, the color levels look more realistic. They've essentially been tone mapped, and that's the beauty of tone mapping. You want to use tone mapping whenever you do an architectural scene, a product visualization, or anything that has to be very faithful to photorealism. Okay. Now we can change a few of these settings here to change the way that this thing looks. For example, we can change the gain here. I'm going to leave the pedestal alone. And you know what I'm going to do? I'm going to do an IPR here so we can see these changes update fairly quickly here. Okay, there we go. Okay, so these are the default settings here. Let's change the pedestal. Let's increase the pedestal here. What you can see here is that the pedestal is washing the image out. Very similar to increasing the gamma correction. It's not the same thing, but it's going to wash out our image. So we don't want to increase the pedestal. What we want to do is leave that at the default of 0. Now the gain, I'm going to go ahead and increase that a bit to about 1.2. And you can see that's going to make things a little bit brighter, but it doesn't wash out the image. It increases the brightness, but it does it more consciously to the contrast. It doesn't just blindly wash out the image in this pale gray color. The knee I'm going to increase to about 0.7. And what that does, it's going to brighten up the brights, as you can see. The compression, I can go ahead and increase that to about 4, so twice that much. It's going to compress the color. So now that brightness that was blown out right here in the wall when we increase the knee gets checked under control, and it allows the background here of the environment for the colors to come out a little bit better, which looks a whole lot better than it did before. And the gamma, I'm going to leave that at 1.4 because it looks pretty good. Now let's just do a complete render of this just to see the whole thing. So again, gamma correction and tone mapping is extremely important for doing photorealistic renders. You really can't do a photorealistic render without doing tone mapping. And that's simply because of the way that CG images are rendered out. A CG image is rendered out for a computer screen. And on a computer screen, you're very limited to the amount of color range that you can show. So by doing tone mapping, we basically change the color range to match up better with photograph or the human eye, or even film. And tone mapping allows that color range to be displayed better on a computer monitor, like this one. So it looks better. So here's the before. Looks very fake, very CG-ish, very nasty. And here's the after. Looks a bit brighter, looks a bit more visible, and looks just more realistic. The color levels are just more manageable. Okay, so let me go ahead and close that. Okay, so that's going to do it. Let me go ahead and close that attribute editor window right there. The next thing we will need to do is increase the amount of samples on the area lights. So let's go ahead and let's do that. I'll start off with this one, open up the attribute editor, and for the high samples, I'm going to increase that to 32. I'm going to do that for all the lights, and this one already has it applied to it, and this one as well. Okay, so these are all three at 32 samples. Great. The next thing to do is to go to render settings and go to the quality tab. Now over here we have adaptive sampling. We can go with adaptive sampling and have Maya control it, or we can go with custom sampling and we can control it. So I'm going to put this to about 3 and 1 for the minimum. And I'm also going to reduce the anti-aliasing contrast. When you reduce the anti-aliasing contrast, what's going to happen is areas that have more contrast are going to receive a lot more anti-aliasing, the maximum level basically. Okay, so reducing the anti-aliasing contrast from 0.1 to about 0.05 is going to give us a much higher quality image, but it is going to take a little bit longer to render because there's going to be more anti-aliasing performed on the pixels of the final image. Okay, the other thing I want to do is change my multi-pixel filtering filter over here. I want to switch to a Mitchell filter, and normally what you would do is increase the filter size, but fortunately in Maya 2009 that goes ahead and it does it for you automatically. So you can see the filter size adjusts based on the filter you choose. So triangle filter is size of 2, a Mitchell filter will be a size of 4. Okay, everything else looks good. I've already adjusted my ray trace settings and I'm going to leave them alone. And now with all these settings pretty much finished, I'm going to go to the Common tab, and then here again you can change the size of the image. The larger you render, the longer it's going to take to render. I'm just going to render out a 640 by 480 render here, so it doesn't take too long. And I'm going to close that, and everything should be good to go. I got my global illumination, got my area lights with high shadow samples, and everything looks pretty good. So let's just go ahead and render maybe from this angle over here and see how that looks when it finishes. Okay, so it took me about 7 minutes to render this image out, which looks pretty good. And this is the before and the after. Huge difference here. Let me go ahead and remove this image. So that's what we have. I invite you to go ahead, tweak the scene, play around with the scene, maybe change some textures or shaders around, maybe change some lighting and colors and things like that. Interesting challenge would be to try to make it look like it's a different time of day. So that's going to do it for this chapter on global illumination and using it in an actual production scene to come up with a great result. So I'm going to close that. I'm going to end this here, and I'll see you in the next video.